Good evening, ladies and gentlemen. My name is Vardhan and I'm super excited to be here on Edureka Live with you guys. In my previous session on DevOps, I explained how to Dockerize an Angular application using Git, Jenkins, and Docker. So today's session is the next in that same Docker series, and today I will show you how to use Docker Compose to containerize not just one Angular application, but to containerize an entire mean stack application. So in simple terms, the difference between my previous session and today's session is that in my previous session, I created one Docker container and hosted one Angular application inside that. But this time around, I will be using Docker Compose to create 3 different containers for hosting the entire mean stack application. Angular will be hosted in one container, same as before. MongoDB will be hosted in another container. Node.js and Express will be hosted in the third container. And that's how I'm going to use Docker Compose to containerize this entire application. All right? And guys, if you get any doubt during the session, you can raise them by putting them in the comment box, and either my team or I will myself answer them for you. So sit back, relax, and enjoy Edureka Live for the next 30 minutes to learn how Docker Compose can be used to containerize multi-container applications. But before I get started, I want to ask you all people a couple of questions. Firstly, are you all aware of what Docker is? And secondly, do you all know what a mean stack application is? It's very important I know what kind of audience I have today. So do drop in your questions, your answers. Okay, so I expect a mixed response anyways. So some of you people might know what they are and some of you might not. So don't worry guys, as you can see from the agenda, I will first introduce you to Docker. I will talk about what Docker is and how beneficial it is. After which I will talk about what exactly Docker Compose is. Alright, then I will tell you how to build Docker containers and how to get them to interact with one another. Since I'm containerizing a mean stack application, I will also talk about what is a mean stack application. That will be very brief. And finally, I will give you a demonstration of how to containerize this application. All right. So enough talk. Let's get started with our first topic for today. And that is, what is Docker? So Docker is a containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works seamlessly in any environment, be it development environment or testing environment or production environment. So as you can see from the image on your screen, we have 2 different containers here, right? So each of these containers, they have their own set of applications running. It contains its own dependencies and packages and libraries. These are tightly packed together. And these containers are powered by the underlying Docker engine. And this Docker engine is in turn hosted by the host machine. The host machine here can be anything. It can be Windows or Mac or even Linux for that matter of fact. Now, in the industry, what happens is Docker is hosted either on servers or inside a VM on the server. All right. So now, in case if you have a big application, then in that case you will need multiple servers for running the different web services, or probably run multiple virtual machines inside that server. Now, keeping cost cutting in mind, virtual machines are the way forward, right? You'll be using virtual machines for running and deploying these applications or web services, and then you'll have to, of course, start multiple VMs in that same server, right? And what would happen when that happens is that you'll have a problem of memory resources. Too much RAM will be consumed from your host because VMs need memory to be pre-allocated. But that's where Docker comes, right? And the benefit with Docker is that much RAM will not be consumed from the host machine. Only the application and its dependencies will be packaged together and will be hosted on top of the host machine. And whenever the container is active and running, only then the memory needed to it is allocated to it. And well, there is no wastage of memory resources as well when you compare it with VMs. So that's one major benefit with Docker. And other benefits with it are, since these containers are very lightweight, they can be easily spun into action without much overhead, and they can also be shared with other collaborators easily by uploading them to the Docker Hub. So these are the reasons why Docker is the way forward and why you have to implement Docker in place of virtual machines. Okay, so that's about Docker. And now let's talk about Docker containers, right? Because this is the actual deal. whatever we do, whatever applications we host, we do it inside this. So that's why it's really important to know how to first of all create a single Docker container. And as the line here says, Docker files are used to build a Docker image. Okay, so these Docker files are used to create a container, and they are these containers are spun by building the Docker image. Okay, and well, this Docker image will also contain all the project codes and all its dependencies and all these things. So that's what the Docker image will have, and it's a simple process to just run the Docker image, and you'll have a running container. Okay, it's just a running version of the image. And the same Docker image can be used to spin n number of containers, and each of these containers will just have slight modifications to the underlying base image. And by doing this, you save up on a lot of memory space. It's not like you'll be downloading multiple Docker images, right? Even if you have the same base image, you won't be doing it multiple times. So you will have an existing base image. On top of that, you will have slight variations, and this saves a lot of memory, and a lot of advantages come up with that. And whatever image you come up with at the end, it can also be uploaded to the Docker Hub, and it can be shared with other collaborators for testing or deployment or for production and all these various reasons, right? And as you can see from the image, this is a pictorial representation of what I just said, right? So you have the Docker container over here. So these are the actual deal. This is where your application or your web service is actually hosted, okay? And these containers are built with the help of the Docker image, okay? Now, building the Docker image is the challenge, and we can simply build a Docker image by writing a Docker file, right? Now, the Docker file, you will mention which base image you want to use, because that base image would have to be pulled for the first time from the Docker Hub, and then you would have your own variations to that. You would have to install certain dependencies. Then you have to install, copy your project code over there, and there are so many other things that you have to do to that Docker image. And when you've done whatever you needed to do, by simply running that image, you create a Docker container. Okay, so the Docker container is just a running instance of your Docker image, and when you just have the container up and active, then you have the service hosted. So you're all good, and at the same time, you can share this Docker image with other people by just uploading that to the Docker Hub. And what happens usually in the industry is that the image is uploaded to the Docker Hub, and at the staging server or at the production server, over there the Docker image is pulled from the hub, right? And then it's just straight away just run, so that you have a running instance of whatever you build. So this way there's also stability, because you're sure that the container is going to host the application in exactly the same way that it was built in. Okay, so there's not going to be any changes with respect to performance. So it's going to be very stable, and it's very reliable. So these are the two big benefits by creating the Docker containers compared to any other VMs or hosting them simply on the server. So that's the one thing. And now that we've spoken about how to create containers, it's time to go to the next topic, and that is, what is Docker Compose, right? So the definition says Docker Compose is used to run multi-container applications. Now, based on what I've covered all this time, can anybody give make a guess as to what this means, this line? Multi-container applications? Anybody from the audience? Okay, so guys, as I said earlier, multi-containers, right? So, well, the thing is, you use one container usually to host one service, right? Now, that's what we discussed all this time. Now, let's take a case of a massive, big application, all right? And it has multiple services, and in fact, there are multiple web servers which need to be placed separately on a particular server or on a particular VM, because it might cause an overhead, because maybe 2-3 servers cannot be hosted on the same machine. So at that time, what we usually do is we have a new VM, and we host it there, right? Or we have a new server altogether. For example, if you want to monitor your application, then you might probably use Nagios. So Nagios, there will be times that you will have to host it separately in a different machine. And similarly, you will have various servers like Jenkins and many web services. So at that time, you instead of having a different machine or having a different VM, we can simply have a different container, Okay, you can have these multiple services hosted in these multiple containers. So each container will be hosting one service, and then these containers would be run such that they can interact with one another. Okay, exactly how it works in the in case of servers or VMs. So it's exactly the same way, but it's just that it's going to be one command, a very simple command, which is going to get your Docker Compose up. And this Docker Compose up, it's like a grid, right? So it'll run all the three containers at the same time. It will host all these, and it will get them to interact with one another. So that's the benefit with the Docker Compose, and that's the whole point of today's session, right? I want to show you how awesome Docker Compose is this way. So yeah, moving on to what I'm actually going to show you in today's session. I'm going to show you how to set up a mean stack application, like I mentioned earlier. So first of all, the mean in mean stack has four different things. So the M stands for MongoDB, which is the database, and E stands for Express, A stands for Angular, and N stands for Node.js. Now together, this is a full stack application. Okay. Now since we are using a combination of these four tools, we acronym it to a mean stack application. Okay, that's what it's acronymed to. So this full stack application is again a web service, so such that you have a front end client and you have a back end server, and then you have a database. So whenever you have your clients or your customers interacting with your web server, they would be interacting with the client. Okay, the client of your front end client. So the data that they pass over there, right? Whatever actions they perform or whatever requests they make, that would go to the client. That would go to the server, and the server would do the necessary function. So it would have to sometimes need to fetch the data from the database. So in that case, it would fetch the data and provide a response, or sometimes it might have to do various other functions. So the actual functionality would be done by the server, and the displaying part would be done by the client, and the actual data would be stored inside the database. So that's how the full stack application works. It's a combination of these three services: a front end client, a back end server, and a database. And that's what I'm going to use, right? So if I want to have these three services, then I would have to create three different containers, right? So I have container number one, which I can use for my MongoDB, which would be my database. I have container number two, which I can use for my backend server. I'm going to use Express and Node.js in combination. And the third service that I'm going to use is my front-end client. Okay, so I'm going to use Angular for that purpose. Now, I'll be hosting these three services inside these three containers, and each of these three containers would be built from their respective Docker files. Okay, as you can see, there's Dockerfile 1, Dockerfile 2, and Dockerfile 3. Now, in the same way that I explained in the previous slide, we have a Dockerfile which would build the image first, and then that would be spun into a container. The same process follows here also. Okay, it's just that for each of these containers separately, we would be using a Dockerfile, and each of these Docker files would be called one after the other with the help of our Docker Compose file. So compose is what is the key term that you need to note here, and the compose file it's a YAML file basically. Okay, yet another markup language. And in the YAML file, you specify the location where your Docker file is present, and then you also specify the port numbers that container needs to use to interact with the other container. Okay, and at times if you have a database in place, you might also have to specify the link of the database. The server and the database need to be connected. So for that purpose, you do that. So that's how the Docker Compose works, and that's the overview that I've given you. Right, three containers, built from three Docker files, which would be called by the Docker Compose file, which is a YAML file. And there you go. You will have a web application hosted that's up and running. All right. So I hope this slide is clear, and I hope everyone here has gotten what I wanted to put forward to you all. And for those of you who still have a slight bit of doubt over what a mean app is and what exactly a mean stack application does, I'm going to give you a brief over here. Okay. So a mean is nothing but a full stack application that involves the combination of these four technologies: Angular, Node.js and Express, and MongoDB. Okay, so the three services that my mean stack application involves are primarily the front end client, the backend web server, and the database. So this is the same thing that I explained a couple of minutes earlier, but since you have a pictorial representation, I hope this can you can relate to this better, right? And my front-end client is going to be my Angular, and the backend server would be Node.js and Express, and database is going to be MongoDB. Okay, so you guys shouldn't have any problems now, and these three services would be hosted separately in the three different containers. Okay, and that would be built from my Docker Compose file. So that's what I'm going to do now. Now let's see how to containerize and deploy a mean app by using Docker Compose. Great. So first of all, let me open my virtual machine. So guys, can you please confirm if you can see my screen, my virtual machine here? Can you give me a confirmation, guys? Okay, great. So first of all, I have my terminal here, and I want to show you my project. Okay, so this is my main stack app is the folder where I have my project present. So as you can see, there is one Angular app folder which is basically containing all the codes of my for my client for the front end. This is the back end server where all my codes are present again, and this is the compose file which I've written, and this Docker compose file is what is going to do all the work for us. Okay, it's a really simple work. And one thing you might notice here is that I don't have a Docker file for my MongoDB, right? So I mentioned earlier that I would be using a Docker file for creating the third container, but in this case, I don't really need to do that. Okay, so a Docker file is a little complicated procedure, but for my database, I don't need to build something from scratch, and I don't need something customized. So I can just simply use an existing MongoDB image which is there on the Docker Hub. I can use that and link that with my backend server. So that's why I don't have that. But instead, I've directly called that MongoDB image over here. Okay, so this is the YAML file, and if you guys are watching this video at later point of time, you can also relate and you can understand what I've specified here, because I've mentioned in comments, I've mentioned what each and every line does. Okay, so it'd be helpful for you people. Do come back and have a look at this later if you're having any problem. But in the meanwhile, let me explain each line here. So in the first line, we are saying the version to be used is 3.0. Okay, so you have to install a version of Docker Compose separately, and Docker Engine will anyways be there, right? And you have to download a version of Docker Compose which matches your Docker Engine version. Okay, because certain versions of Compose is not compatible with certain versions of Engine, so you have to just look up the right version. And I'm using version 3.0 of Compose, and I have version 1.16 of my Docker Engine. Okay, so just make note of that. And yeah, you got to specify the version. That's going to be your first line, and after that you simply specify the different services that you want to run. Okay, the keyword for that is services, and you give a colon here, and you specify the three different container names. Okay, and each of these containers will contain the actual services. So in case of my Angular, this is going to be the name of my container number 1, right? And here I'm saying build this container from the Docker image that is present in this particular folder, this particular path. Okay, similarly, Express is the name of the second container, and I'm asking it to build this container from the Docker file that's present in this particular path, Express server. In case of my MongoDB image, I'm creating the container with the name of database, and I'm not giving a Docker file here. I'm just saying pull the image from the Docker Hub. Okay, so it would use a image that is the Mongo image with the latest tag, and it would use that. Okay, so let me just quickly go to my folder and show you where the Docker files are present. So this is the Angular app. Now since my compose file is here, from my compose file, this is the path where my Docker file will be present, right? So this is that Docker file. So let me just open this Docker file and keep it here. And similarly, if I could just go back, there's Express server folder, right? So this is the code where my codes for server side is present, and my Docker file for that is present over here. So now coming back to my YAML file, after specifying the path of each of these Docker files, I'm specifying the port numbers on which they should be running inside my where the port mapping, how the port mapping happens. So whatever application you're hosting inside the Docker container, right, that would be hosted in one particular port number of your Docker. So you have to map it to one of your port numbers of your local host machine if you want to see the UI. If you want to interact with your web browser, then you have to map it with a particular port number. Okay, so I've said this is going to be the local machine port number on which it would be visible, and this is the port number on Docker where the application is going to be running. Okay. Similarly, for Express, it's 3000 colon 3000, and for MongoDB, it's 27017 colon 27017. So each of these port numbers are default for these applications. Okay, so I haven't done much of a deal over here. Let me just, since I've explained the YAML file in a decent fashion, okay, there's one more thing left. There is links. Okay, now this line, if you see, I'm linking my server side to my database. Okay, now since I have a database where it needs to fetch data from on a regular basis, we have to give the keyword links with a colon and just specify the container name. So that's why my third container is going to be the MongoDB container. It's going to have the container name of database, and I'm linking that over here. Alright, so it's pretty simple. And now that I've explained each of these compose files, it's time I explain the Docker files. So this is the first Docker file which I created for my front end, and it's very similar to the Docker file that I used for my previous session. If you people remember, if any of you are were there in that session, you might realize that first of all, I'm using a from command to pull the node image, okay, with the version 6. I'm doing this from the Docker Hub, and inside this image, I'm creating a new directory, okay. Make directory is the Linux command that you use. I'm doing that with the p flag. I'm creating this path, okay. So I'm using the p flag so that I'm creating the entire path, the parent path also, /user/src. Okay, so I'm creating this folder inside my Docker image, and I'm changing the working directory to the newly created folder or newly created path, okay, project path. And what we need to do is we have to copy all your dependencies. You have to copy all your project codes and all these things, right? So that's what I mentioned when I was delivering the slides. All your project codes, all your applications codes, the dependencies, libraries will all be packaged together. So that's what we are doing here. I'm first saying copy the package.json file to the project path. Okay, now if you can let me just show you the package.json file. So this is the package.json file. First of all, I'm copying this one inside my Docker image. Now that's because this file is the most important file which has details about which version of dependencies are needed for your code. So for my Angular code, which is present over here, by default my Angular code would be present in src/app path. So whatever I would need, the versions of that dependencies would have to be mentioned in the package.json file. Okay, so I'm copying this file inside my image first, and after I copy it, I'm running a npm cache clean command. Okay, so npm stands for node package manager. It manages your application here, and cache clean is I'm just removing the cache here. It's not a very important command, but the important command is npm install. So when you give the npm install command, what this does is it would first of all look for the package.json file. Okay, the npm, which is node package manager, would look for the package.json file, and whatever versions of dependencies are mentioned inside it, those would be downloaded. Okay, and they would be present inside a new folder called nodes_modules. Okay, so that would be created, and it would have to be moved to this particular path inside your it should be moved inside your Docker image, right? So that command is what I'm doing next. So after downloading the node_modules, all the actual dependencies, that along with the actual project codes, so those also I'm copying by giving the dot command here. Okay, so when I say dot, whatever is present in the host machine, everything in that particular path would be copied to my Docker container path of this, and then I'm simply doing an expose 4200, indicating the fact that I want this container to have an open port at this 4200. Okay, and the same 4200 is what I'm using over here. Since 4200 is where Angular is hosted, I'm mapping that to my host machine's port of 4200. Okay, this I do in the YAML file. But anyways, when I specify the port number where it's running, I can simply do an npm start command. Okay, and when you run an npm start, it's you're starting a node package manager, which would straight away look for your codes. So your codes would be present inside the src folder. Okay, you have another folder called app, so it would look for everything here, and whatever is present here, it would start executing them. And yeah, that's how, of course, the dependencies would be present inside the same image, so your application would be successfully hosted in that way. Okay, and similarly, going to the second Docker file, this is for creating the server side. Okay, and if you can notice, there's not much of a difference. So almost every step is the same except for me exposing the port number here. So I'm saying my server would be hosted at port number 3000 of my Docker container. Okay, and this again I'm mapping in the YAML file to the host machine port number 3000. Okay, so that's the only difference. This is the only difference in both the Docker files. And now that I've also mentioned where these files are present inside my YAML file, I can simply execute this Docker compose file to have my to have my servers hosted. So the command for that is, let me check where am I right now. Okay, home/Edureka. I'm going to cd to the folder, and here we have the same set of files and folders, right? So this is the file that we want to execute, and the command to execute the Docker compose file is docker-compose space up. Okay, there's a very simple command, and your Docker file would basically be executed. As you can see, it's starting the Angular 1 container, database 1 container, and the server side container. Great. So guys, this is going to take a minute, and I would suggest that if you guys have any doubt so far, do drop them in the chat box, because I would have a minute to look at your questions. Let's just wait for 3 of our servers to get hosted. All right. Okay, the ng live the development server is listening on localhost 4200. Great. This is an indication of my client side. Okay, so it says webpack compiled successfully. That's great. My web service is hosted. Now what I can do is I can open my web browser here and go to those particular port numbers and see if my service is up and running. So if you remember, my client is hosted at port number 4200, right? So let's hit enter. I can either give localhost or I can give 0.0.0.0. Either of that will do. And as you can see, my Angular client is up and ready, and my app is simply about having a form page. Okay, so I can add details here, my first name, last name, phone number details, and I can just click on add to get the details, and that details would go to my database. So that it's a very simple application which we've created. And similarly, you can verify if the server is running by going to the port number where it was hosted. And if you can recall, this was the port number it was hosted on. Foobar, great. So this was the authentication that I needed, and localhost 27017 is where MongoDB is hosted. So for MongoDB container, you'll get a message like this. It looks like you're trying to access MongoDB over HTTP on the native driver port, and if you get this message, it means your container is up and running. Very good. All right, so we can just test our web application by giving the name details here. Okay, so the first name, let me say, I'm going to give my own name. I'm going to say Vardhan. All right, last name, I'll give NS. Phone number, I can just give a random number here. Okay, and if I say add, this data would go into my database. That's my MongoDB container. All right, great. So it shows that already I have these details present. Okay, so I have this one record, and now this record has been added. Okay, now let's verify that by making an API call. Now I've only explained the client aspect. The server side aspect is something that I didn't explain, right? You guys should know by now that the client will take the request from the server would take the request from the client and query on that, right? If there's a if there's a request to access the database, then it would fetch it from the database and respond to the client. So let's do that. This of course is the UI that I created, which shows my database. But anyways, to verify if the same thing has gone into my database Actually, we can do that by going to the server here and going to this particular URL. Okay, there's a slash API slash contacts, right? So this is basically a API call that my server is making, and at this URL at slash API slash contacts, it can view what data is present inside my container. So it says that the first record that is present is this one. It has an ID of this, which was generated automatically, and of course the first name, last name, and the phone number was what was given. Okay, and this was the record that I created recently, and as you can see, even this is present. So if you want if you want to play around a little bit, you can do that, and let me just do that by deleting one of these records. Okay, I'm going to delete the first record, and now if I just go back and refresh this page, you can see that the first record is gone. Okay, so we have just Vardhan, we have NS, and the phone number. Now that's because we deleted that from the database itself, and I made a call from my server, from my client, sorry. So I hit a delete button from my client. That request went to my server first, and the server would indirectly go to the database and delete that particular record. And since I did a slash API slash contacts, since I refresh this would return whatever is present inside the database. So it's that's what is visible here, right? So currently this is the only record that is present in my container, in my MongoDB database, right? So that's what's visible here. And similarly, these are just two functionalities I showed you. There are a couple of more functionalities that we can do with this image. You can retrieve one particular record if you want to. You can do all these things, okay? And this is just my application. You can come up with your own customizations. You can build your application in your own way, correct? And you can do all these, and of course I cannot go into depth. I can't teach you in detail what the different parts of this application is, but instead I can point you to one of the videos, which is a Edureka video, which has a complete tutorial on how to create a mean stack application. Okay, so let me just give you the link of that video in some time, but before that I just want to quickly show you that this was the Express server page, and again we had the package.json file here, the app.js, which is basically the entry point into my server. And in this app.js file we would have details about what APIs are there, what function calls can be made, and whenever that particular function call is made by the client, then it would be routed to this route.js file inside the routes folder. Okay, so the definition of those functionalities would be present here. So whatever actions need to be performed when clicked on that, the rules will be specified here. So that's how the server communicates with the database and forth, right? So that's how it works. And yeah, that's the explanation of both the mean stack, the complete explanation, right? The Angular app and the Express server. So now that I've explained everything here, let me just quickly go to the video that I was talking about, right? The tutorial about a mean stack application. So if you just YouTube mean stack Edureka, you'll get this video. Okay, mean stack application tutorial, and this is a very good video, and it explains everything that you need to know about a mean stack application and how to create one. Okay, you can get started with creating one, and especially for those aspiring to be front-end web developers, right? Those aspiring to be full-stack developers. It's a must-watch video, right? It's a brilliant video. I suggest you watch this video, and you can throw in your comments if you have any problems. Okay, but anyways, getting back to my session. That's it from my side. This is what I showed you. I've shown you how to add and delete records, and I've showed you in real time that the database gets updated, right? So that's the end of my demonstration, and that brings us to the end of the session, guys. So I just want to also let you know that we have an entire DevOps playlist. So if you want to learn more about DevOps or any of these tools in detail, like what you did today, then you can just check out our playlist, and we'll be uploading videos every regularly. So do have an eye for this playlist. And of course, if you guys are interested in learning DevOps, you can do that by going to our course URL and check out all the details. You can check out the what are the course details, what is the price of the course, and what batch timing you can have. And similarly, it's not just for DevOps, but we also have a standalone course for Docker. Okay, so in our DevOps course, we cover most of the courses. We cover most of the tools like Docker, Jenkins, Puppet, Chef, Ansible, Git, and Nagios. Okay, but this is a standalone Docker course, and if you guys want to learn Docker in detail, then you can surely give it a try. Right. So similarly, this is a URL, and you can check out our course details over here. And yeah, and since you guys have been here for so long, been active in this session for so long, I can give you people this offer. Okay, so there is this link, that is resources.edureka.co. This is something that we'll ping in the chat box. And if you guys want an exclusive offer on any of these courses, not just these two, in fact any Edureka course, then you can just fill in this form. Okay, and courtesy to the fact that you've stayed here for so long and appreciated our session, this is just for you. Okay, for those who fill out this form, you will get this offer. So yep, that's pretty much the end, guys. If you guys have any question, keep them pouring in, and we'll be answering them. We'll be answering them from our end. All right. In the meanwhile, let me just go to my conclusion slide and wrap up today's session. So yeah, first of all, I spoke about what is Docker. I gave you an introduction here, spoke about the benefits, and then I spoke about what is Docker Compose, how effective Docker Compose is, and then I told you what is a mean stack application, and then I finally used Docker Compose to containerize a mean stack application, right? And I gave a demonstration of that. So these were the topics that I covered today, and yeah, that pretty much is the end of my session. I thoroughly enjoyed this live session, guys. I liked the activity today, and I hope you all learned something new. We will come up with more live sessions. Do subscribe to our channel, like, comment, and share our videos. And it will be a pleasure to have you on board with us. Okay. And if you want to be notified of such sessions in the future, then I would want you to hit on the bell icon here that comes next to the subscribe option. So you'll get notified of all these live sessions, and of course, we want you to subscribe to our channel also. So yeah, it will be a pleasure for us to have you on board with us, guys. So thanks once again, and happy learning.